Good afternoon, everyone. Can you guys see my screen?
Yes,
Yes,
sir.
sir. All right, great. So let's make a start with today's class. Now, what we're gonna be doing, um, we're gonna there's a change of plans. I was supposed to start this since last week, implement this plan since last week, but I forgot. Um, so a reminder once again um, that we have five major topics that we need to cover, would have covered, and we have five parts of the SBA. Please remember the rule of completing, or the requirement, not rule, the requirement of completing the first four parts of the SBA stands for you guys too. So ensuring your spreadsheet is complete, your database, your word processing, and your web page. Now, the plan was to not go into web page content because we can cover that later on. You guys should already have an idea as to how to create your web page because it's relatively simple, and I explained it in a video already. But just as a simple reminder, um, we have what are called website builders, and you simply choose whichever one. So we have Wix, we have Weebly, Squarespace, GoDaddy, WordPress, and I'm pretty sure you guys know about Google Sites. Those are all examples of um, website builders, and you're going to basically be using a website to build your web page, your website. So you simply go on YouTube, follow some tutorials as to how, but it's relatively simple. Even if you don't watch any videos, it's relatively simple to create a website. It's just like if you're creating a Word document. So that shouldn't pose a challenge for you guys. What we're going to actually be doing is heading into your programming part of your content, and thus also starting the programming part of the SBA. So this is why I've been asking you guys to try to finish off your SBA, the first four parts, so that we can start our programming also. So with that in mind, our first topic of today is going to be chapter 9.1, which is Introduction to Problem Solving. So we're starting programming from today. The reason why I'm also starting programming instead of doing the web page is because of time. Remember, we only meet once a week, so we need to start early with programming so that you guys can get enough coverage so that you can do your work. Um, so let me give you a breakdown as to how programming is going to run. Now, in summary, the programming aspect of IT teaches you how to create a program. That's in summary. Now, what it also does is that it teaches you a skill, and that skill is the problem solving skill. Now, it's something that we as humans naturally have, a problem solving skill. But some persons don't realize it, and some persons don't know how to um, apply it when they really need to. We do it sometimes unconsciously without even realizing it. For instance, say for instance you want to buy ice cream. So you have DQ and you want to go and buy ice cream. And the day you go and choose to buy ice cream, DQ is closed. So the question now is, what are you going to do? That's the problem. You want ice cream, DQ is closed. What are you going to do? Are you going to go that day without ice cream? Or do you have options? Can I go to Demico? Can I go to Igloo? Can I go to Cream Select? And those are things we naturally do. We, and that's in essence what is problem solving. Problem solving is that we basically have a problem. It could be any problem, not IT related only, any problem. Like I mentioned in this example here, I want ice cream, I want it from DQ, but DQ is closed. And with problem solving, we simply come up with various solutions. What are my options seeing that DQ is closed? What should I do? Should I go somewhere else? Is there anywhere else I can go? Or do I wait another day? Is it a case maybe they might open in another hour? Maybe I'm early and they might open in another hour. Maybe one option is that I could wait until they open. So that, with that in mind, we can apply that problem solving skill into various scenarios of our life. Say, for instance, you finish school, you write your CSEC, you finish school. Um, by the time you get your results, it's too late to apply to UG. UG closed off. What are you going to do? That's a problem there. You want to get into UG, but UG closed off. What are you going to do? How are you going to solve this problem? How are you going to fix the situation? Problem solving skill. So, even though this final topic that we're going to be covering, programming, it's how to develop a program. In essence, it teaches you how to solve problems effectively, how to find solutions, how to look at how one problem is better than the other, how to select the most appropriate, and things like that. So keep that in mind. A lot of persons, they, because programming is so technical, they run from it. It's understandable because you don't see the need for programming in IT. But like I said, it's something that teaches you, it's like a mindset kind of thing. It teaches you how to think effectively, how to think in a way that can help you to make better decisions in life. So, with that in mind, we are going to start with chapter 9.1. The general topic is problem solving and program design. Introduction to problem solving. Now, as I mentioned, remember this topic can be very technical, may not be something you're already familiar with. So it might be something that you might not readily understand, you might not be too clear on it. So please ensure if you're not clear on something, you ask questions because, like I said, it's gonna get very technical, and programming is very heavy in your exam. Good afternoon. Programming is very heavy in your exam, on your exam, in your exam, whichever one it is. And you need to ensure you're clear in it so that you can succeed in your exam. So, with that in mind, any questions before we begin? Any comments? All right, let's go ahead. Can you guys hear me though? Just in case. Let me verify.
Yes, sir. I can hear you.
All right, great. So let's start with introduction to problem solving. Now, this first paragraph you would have covered in third form. So software is a name given to computer programs that tell or instruct the hardware how to work. So that's a simple definition for software. And that's what we are basically going to be looking at to create. A software is simply instructions that tell hardware what to do in simple terms. Now, software therefore includes computer programs that create system and application software. So that's point number one. This is point number two. You would have also learned in third form that we have two types of software. We have system software and we have application software. Now, each program exists because a problem first existed and a solution was needed to solve that problem. So, for instance, um, let's see, the problem, or we can talk about Microsoft Office. Was there a problem that made Microsoft want to develop the Office applications? Was there a problem? Can you think of anything? Or there was no problem? They just decided to make application.
So the problem might be downloading individual apps and not having enough space for it. So they create one app with everything.
Okay, could work with that. Yeah. What about productivity? Um, think back before computers. Would doing everything manual be more effective than using the software?
No, sir.
No. So, would you guys, as some of you are business students, you might be studying business subjects, would you like to do um, all of these accounting, all of these? Yes, you might be doing it now physically, manually, but we know that there's actually software for everything. So, like, if you get into the business world and you're working for somebody, would you like to continue to do everything manually, paper, book, and so on? Or would you prefer to use some sort of software that would make it easier? Which would you prefer?
I prefer the software.
The software, because it would definitely make the task easier. It's going to calculate for you, create a template for you, make things easier. So software usually try to solve some sort of problem. It's something, some sort of issue. Even if it's not an issue, it could be that it's simply trying to make something more effective. Maybe something takes too long to do manually, physically. That's an issue there. And we're simply trying to allow the software to do it faster for us. So that's why we create software. Now, solving a problem, our next topic. You should first develop an algorithm to solve the problem. Now, this term here, you need to take note of it. You need to memorize it. It's a key term that we're going to be using a lot. So, the first thing that we're going to have is a problem. That's the first thing we're going to have, a problem. Some sort of issue. Something is taking too long. Something is taking too much time. Well, that's the same thing as I said. It's too much work to do. So you should first develop an algorithm to solve that problem. So that's the next step. You have a problem, you find a problem that you want to solve, and you create an algorithm for that problem. You don't create a program. You don't just jump into creating a program right away. We can compare it to building a house. Now, when you're building a house, do you just go and start building a house just like that? What do you do before you build a
No,
house?
sir. Need a house plan.
You need a house plan, right? So you plan how you're going to build that house. Similarly, with programming, we don't jump into creating a program just like that. We can, just like how you can jump into building a house just like that, but it will not be as effective as if you had planned. So similarly, for creating a program, we have to plan. And creating an algorithm is how we plan for that program. That's simple. So what is an algorithm now? How can we define it? Well, an algorithm is a sequence of precise instructions which results in a solution. It is a sequence of precise instructions which results in a solution. So, in simple terms, it is a list of steps that tell you exactly what to do to solve a problem. From step 1 all the way to the very last step so that you can solve that problem. So let's see how we can create an algorithm now. Let's create an algorithm. So let's create our first algorithm. Now, let me see who can remember what we just looked at, what we just discussed. What's the first thing we need if we're going to develop an algorithm?
Before you even get to, I need a problem, sir.
Very good. We need a problem. So, what's my problem? My problem, I'm hungry. So, notice I'm not talking about computers because remember, what we're learning, we can apply it to anything in our lives. That's how programming actually works. We can apply it to anything in our life. So, the problem in this case here is that I am hungry. Now, let's create an algorithm. Step 1. If you are hungry and I am hungry, let me add more to the problem. I am hungry. I would like to eat a sandwich, a chicken sandwich. That's my problem. I'm hungry. I would like to eat a chicken sandwich. Let me hear what is the first step you would take to try to solve this problem. Anybody? What's the first step?
So I would get the resources to make it.
So, get ingredients to make sandwich. Good. What else would we do? I guess only people who know how to cook might be able to answer these questions.
Yes, sir. And then so you get the ingredients, and then you have your steps. You plan out your steps, or like get a recipe.
So, get a recipe. What else? What else would you guys do? Give me a logical step. What would you do? Amlino.
Um, make the burger.
All right. Make the burger. That's it. Anybody want to add anything else? Anybody wants to rearrange the steps? Because let me give you a hint. Um, let's see. All right, it wasn't mentioned here, but the algorithm should be in a logical order. So, like for instance, step 3 should not be eat the burger, or in this case, is a sandwich. We shouldn't say eat the sandwich, and then we have make the sandwich as step number 3. That's illogical. You can't eat it and then you did not make it. So eating has to come after. So our steps needs to be in a logical manner. So once again, anybody wants to rearrange any of the steps? Anybody wants to add anything more so that we can get a sandwich?
So I could switch recipe 1 and 2, just put 2 at the top and then 1
Good.
second.
Very good. Good. Because we got to get a recipe before we can know what ingredients we need. Good. Now, all right, let me work with this here. Now, so that's one characteristic I mentioned there about an algorithm. Hope you guys took note of that. So let me put it at the bottom here. Characteristics. So we mentioned that it must be logical. Now, another characteristic is that it must be precise. As we can see in the definition here, an algorithm is a sequence of precise instruction. The word precise is indicating that it should be um, an indication of a simple task, one simple task. Like, for instance, getting a recipe, that's a simple task. You can't really break that down unless you can say, unless you want to say, um, like, for instance, uh, using your phone, open, well, using your phone, open Chrome, and search for a sandwich recipe. So notice what I did there. I broke down these steps here into smaller, more specific steps, more precise instructions. So that's the goal of an algorithm, not to have general steps like just saying make the sandwich. We actually have to break this down into parts. We have to be more precise. So we can say using your phone, open Chrome, search for a sandwich recipe. Then we're gonna say select a sandwich recipe and then get the ingredients to make the sandwich. Now, what do you think will have to happen after you get the ingredients to make the sandwich? Or what else could we indicate for getting the ingredients to make the sandwich? What precise steps could we write down or could we make?
You could like go to the grocery store or something to get the
Exactly.
ingredients.
Exactly. So at this step here, you can say um, write down ingredients. Then at this step here, step number 5, you can say go to supermarket, purchase ingredients, take home ingredients. So you see how precise we're being here, how specific we are being here. And that is what is needed for an algorithm. You must be clear. Like for instance, if you just say get ingredients, how are you getting these ingredients? Are you gonna go and buy it? Are you is it already in your fridge? So you simply go into your fridge and take out the ingredients? Are you gonna jump over the fence and go by your neighbor, open their house and take the ingredients from their house? How are you gonna fulfill the steps? So you have to be clear. When a step doesn't specifically say what to do, you have to be clear as to what you should actually do at that step. So after take home ingredients, you can say prepare ingredients, but then you can even break that down further and say how are you going to prepare it, how are you going to prepare the ingredients, how are you going to make the ingredients, and then finally, how are you going to eat the sandwich, things like that. And
I like
that,
to say,
yes, go ahead.
prepare the ingredients using the recipe from the website.
Good. So follow the instructions as to how to prepare the recipes. Good. Sorry, the ingredients.
Or like um gather the ingredients in the right amounts needed.
Mm-hmm. Yeah, all that can work. So, with this in mind, this is basically how we create an algorithm. Notice there is no like specific rule as to how we should type something, or there's no specific formatting like we got to have like 10 steps, we have to have 20 steps, or we must have a certain starting point, we must have a certain ending point. There is no specific rule on those things. But the major guideline that we must follow is certain characteristics that it must have. It must have the steps in a logical manner. Obviously, you got to do something before you can get to another step. You got to get the ingredients before you can prepare them. So it must be logical. And your steps must be precise. Or, as I mentioned, it should be specific, telling you one logical thing that you should be doing. Like, for instance, the very first one, using your phone, open Chrome. That's simple. If we could break that down further, we should if we could. But otherwise, if it is a specific action, then that is good enough to be a step. So, using this method here now, we can create an algorithm for almost anything. Because all an algorithm is, it is a sequence of precise instructions which results in a solution. So, a precise set of instructions that takes you from having a problem to solving that problem. That is what simply is a algorithm. And once again, as you notice with the example, you're simply writing straightforward what you should do in each step. Write it out exactly as you can describe it, whatever the action is. If it's cut up the shallot, crack the egg, put it into a bowl, mix the egg, whisk the egg, add in salt, exactly what you should be doing, that is exactly what you should be describing. Because why you want to do that is so that if anyone else is to read your algorithm, because that's something you need to keep in mind too. Programming, creating algorithms, and so on, you need to, it's a teamwork kind of effort. A lot of the jobs in IT is teamwork. Everything is about collaboration, working with somebody else. Almost nothing today is a one man thing because something that you're doing, somebody else can continue working on it, or two-person, three-person, four-person can work on one project. So, like, if somebody is creating a program, it's not one person alone creating a program, multiple persons. These persons are creating different parts of the program. One person might create part A, another person create part B, C, and then they merge everything together. So, in order for everyone to be clear and on the same page, that's where the algorithm comes into play. By writing the algorithm in a straightforward, English like manner, like if you're writing sentences, telling the person exactly what to do, it can be clear so that anyone that is reading it will be able to understand. That is why the last part of the paragraph says if your algorithm is vague and has conflicting logic, you will not get the correct answer. Because if the person is not clear exactly what they should do at a particular step, then remember you will know what you're thinking. But if somebody else reads it and they're not clear as to what to do, they will not get the correct answer. So that is simply what is an algorithm. And that is a starting point as to how we solve a problem. Are we clear on that?
Yes, sir.
The rest of you clear?
Yes, sir.
Yes, sir.
Yes,
All
sir.
right. Good, great. Any questions? Any questions, concerns, comments? Remember, ensure you're clear in everything before we move on. All right, no questions? So let's continue. Now, when we're solving a problem, remember solving a problem, we still, even though I said it can be used in general, we still aiming to create a program. in the long run. So solving a problem is going to have two phases. It's going to have the algorithm phase and the implementation phase. So those are our two phases that we're going to be looking at to solve a problem. Because remember I mentioned that you have a problem and you create an algorithm. So creating that algorithm, you're entering that algorithm phase. So how do you create this algorithm now in this algorithm phase? Well, the first step in the algorithm phase is to clearly define the problem that you want to solve. Clearly define it. So for your SBA, please take note that this is what we're going to call the problem definition. Because this is something you have to create for your program also, for your program SBA. Clearly define the problem that you want to solve. In essence, we call that the problem definition stage of your program. So it's simply you writing a description, like how I wrote here, about the problem. But we can add more to it. So that's just a summary there, problem definition. So we can say the user one day or let's not start with that. So Chris is a person that loves to eat. However, one day he does not have lunch. He searches his home and does not find any food. When he is hungry, just ignore the grammatical issues for now, so that we don't spend too much time on it. He usually experiences frequent headaches and other issues. He can sometimes get emotional, causing others around him to be annoyed. So in essence there, I am describing how the issue is affecting the person. So for problem definition, so I'm giving you a guide as to how to write a problem definition in this bottom part here now. So let me put it in red. So you are describing the effects on the user and those around the user. So simply, how does it affect the person, and maybe how does it affect those who are related or closely in connection with the person? Like how, for instance, being hungry would cause the person to experience frequent headaches and other medical issues. And then by being emotional, the person would cause those around them to get annoyed, to get frustrated, things like that. So in the problem definition, you're describing this issue. What are the effects of the issue? How does it affect the person? How does it affect those around that person? So on. Then in the problem definition, you can, let me see if I'm missing anything here. Clearly define the problem. So what are the effects? So describing the cause and effects. So not only the effects, but the cause. What would have caused the problem? What started the problem? So what started the problem was that he woke up and there's no food in the house. That started the problem. There is no food. Now, how does that affect him? He's now hungry, and then so on. Now, in the problem definition, you would also describe the solution. So you can continue and mention the what is the solution basically? To buy food, to make food, whatever the case may be. But you can only, but this is like for SBA purposes, describing that solution aspect. We're gonna come back to that later on. But in essence, this is what you basically need to describe the problem. What caused the problem and what are the effects of that problem. So that way you get a general idea, a good idea as to what exactly is happening with that problem. So that there is our first step. Are we clear on that? Where's my connection? All right, I think, can you guys hear me? Can you guys hear me? Can you guys hear me? Hello?
Yes, sir.
Yes, sir.
All right, I think my internet connection just dropped for a few seconds. So the last thing I was saying, that for problem definition, we simply have to describe what caused the issue and what are the effects of the issue. How is it affecting whoever is experiencing the issue, and how is it affecting those around or other persons in the area, and so on. So are we clear on how to define our problem? Are we clear on that?
Yes, sir.
Yes, sir.
Good. Now, step 2 for our algorithm phase. We need to propose some solutions and evaluate each one. So, proposing solutions, that should be straightforward. We can say, for instance, where should I put this? Bottom here. Proposed solutions. So we have our problem, person being hungry. What are some proposed solutions? Give me some proposed solutions.
Order food.
Order food. Good. Next.
Make the food by yourself, like homemade.
Make the food. Good. Next.
Get someone to make it for you.
Good. Get someone to make the food for you. Yeah. Anything else? You got any other options?
Ask a friend for food.
Good. Ask your friend for food. Good. Anything else we could think of? What about, yeah, Africa?
No, I was going to say crash a wedding.
Crash a wedding. Good. Crash a wedding. Steal
Attend a wake.
somebody's wedding. Attend a week. Good. So we got a lot of options. We got a lot of solutions. But what we need to do now is to evaluate each one. How would we evaluate each one? What should we look at? in order to evaluate it? What do you look at, or what aspect of something do you look at when you're evaluating it? Two things you would look at when you're evaluating anything. Two things you would normally look at. Nothing. You look.
Sir, could one be how
Go ahead.
could one be how easy or difficult it is to get it done?
So a general term for that. General terms for that. We use it almost every day when we're evaluate.
Assessment.
Huh?
Assessment.
All right. So we need to look. Um, so evaluating. Almost evaluating.
How time consuming it could be?
All right, but looking for more general term. That is correct, but there's two general terms we can use. Evaluating the solutions. So evaluating the solution, you look at the pros and the cons, or the advantages and disadvantages. So when we're evaluating, like you said, we look how one is better than the other. So simply we look at the pros or the advantages, what makes one better than the other, or what makes one time consuming, less time consuming, and so on, or what makes one, what are the cons or what are the disadvantages, what makes one less of a choice over the other. So let's see if we can do that with these options here. What is the advantage of any one of these options here? What's the advantage of any one?
Ordering food is less time consuming.
I didn't hear that.
Ordering food would be less time consuming
All right,
or
good. Uh-huh.
less energy being used.
Less time consuming and energy use. Good. What else? What are the advantages and disadvantages? Either one. Evaluate them
Sir,
now.
if you make your own food, you could guarantee the quality of it.
Good. Very good. Guarantee quality. Good. What else?
Make your own food could like save money.
Save money. But I was actually reasoning on this the other day. Making food. Does making food actually save money in this economy today? Think about it. Do you actually save money if you make food today?
Not really, because remember you still have to buy the ingredients.
But I guess if you can buy it at a reasonable price, then yeah, you're gonna save money. But if you think about it, if you
Still
buy
got to buy gas and all them things.
exactly, and if you spend 1,500 to 3,000, you could practically get food for the entire day. But sometimes that 1,500 to 3,000 wouldn't even get you enough ingredients to give you a proper meal for that day, if you think about it. But like I said, it all depends on how you get to buy the ingredients. But yeah, that's just my reason there. But yeah, you can save money if you make your own food. What other advantages and disadvantages do we have for any one of the solutions?
Getting someone to make the food for you can be safer.
So number 3 could be safer.
And it saves time, sir. You don't have to take your time to get it done. They do it for you.
Which one? Oh, so
The number 3.
saves time. Oceana, what were you saying?
Sir, to crash a wedding, you could go to jail.
Okay. Good. So that's a disadvantage there. Go to jail. Free card.
We could.
We good? Where's that?
We
Yeah, you
could
could.
go to
Yeah.
jail if we
Yeah,
crash.
you could get locked up for
Nice.
disrupting the public or something of that sort. You can go to jail for be locked up for like a little while. Nothing too serious though. Maybe a 1 day, 2 day. But yeah, those are the so you guys get the idea. Going to a wake, you get free food,
Asking your friend for food saves money.
saves money. Good.
Asking a friend for food can be embarrassing.
Embarrassing, so that's a disadvantage. So good. We have the general idea as to how we would evaluate now. So now it's for you now to decide which are you going to choose. The You have to figure out which one has the better advantages compared to disadvantages. So, like for instance, you attend a week, yeah, you can get free food, but the disadvantage is that you're only gonna get what they're offering: biscuits, cheese, coffee, chana, palori. Those are you gonna get. You're not getting no sandwich and pizza and all them things. Whereas if you crash a wedding, you can get cake, yeah, but then you risk going to jail. Um, it's supposed to be steal somebody food. How you gonna steal somebody wedding? Steal somebody food. Yeah, you can steal somebody food. Break into somewhere, break into Pizza Hut, steal the food, go into KFC, take the chicken, jump over the counter, grab all the chicken and run out. But then you risk going to jail again once again. So that's how we evaluate. You try to see which one has the most advantages, or not necessarily the most, but which one would be the most effective to use in your situation, your case that you might have. And that is step number 2. Are we clear on that step? Are we clear so far?
Yes,
Yes,
sir.
sir.
Great. So, step number 3, you select the most reasonable solutions, as I mentioned. You see which is the most reasonable. So, notice it says the most reasonable. Not which one got the most advantages, not which one sounds the best, but which one is the most reasonable. It got a balance, you can say, or it makes the most sense to do. And then you design an algorithm. So you got to try to understand the situation first. Understand what you can do to fix this situation. And then you're going to come up with an algorithm for that solution that you would have created. So we already looked at what is an algorithm. You design an algorithm that is precise and well thought out to solve that problem. So remember, you're only picking one solution because you don't want to create an algorithm for multiple solutions. That won't make sense. That's just going to be time consuming on your part. You can, but it's time consuming. Now, the last step for the algorithm phase, you got to test your algorithm. Notice not to create the program, test your algorithm. You got to test it to see if it makes sense, if it's actually logical, if it actually can work before you go and create a whole program and then it doesn't make sense. It's not going to work. So this is another part of your SBA. This is what we call let me type it. This is what we call the trace table. Any of you ever heard that term? No?
Yes, sir.
All right.
Yes,
Good.
sir.
Good. So the trace table, something that you have to create for your SBA. We can look at that later on in detail. But that is the final step of your algorithm phase, whereby you test your algorithm to see if it is correct, if it makes sense, if it's going to actually do what it's supposed to do. So you must be sure your algorithm works correctly before you can write a program for it. Now, take in mind, we're not doing this test to see if it's perfect, because obviously we won't design it perfect in the beginning. But you're just testing it to see if it makes sense, if it actually working correctly, if you made any illogical errors, basically. One step could be switched with the other. You could refine a particular step, make it more specific, things like that. That's the purpose of your testing. So, those are the 5 steps of your algorithm phase. Any questions on the steps?
No, sir.
All right. The rest, I hope you are clear on the steps. Please remember, if you're not following, if you're not clear in anything, let me know as soon as possible. You must be, yeah,
How are
Stephanie.
you testing the algorithm?
All right. Good question. So you create what is called a trace table. And later on, there's a whole chapter on it. Notice chapter 9.6, testing algorithms. We're going to go into detail as to how we actually test an algorithm. But you simply create in Excel. It doesn't necessarily have to be in Excel, but we simplify it and put it into Excel as to how to test it. I can give you an example. Trace table. It's simply creating a table to document how it's going to look something like what's on the right hand side, a literal table to document your algorithm. But we're not going to get into detail with it now because we're going to do that later. Any other questions? All right, let's move on. So, the last phase, the second phase of solving your problem is the implementation phase. Now, this is where you're actually creating the program in the implementation phase. So, this phase has 3 steps. The very first step is to translate or convert your algorithm using a programming language, or basically into a programming language. You convert your algorithm into a programming language, and notice we have some examples such as BASIC, Pascal, C, or Visual Basic. They mention these 4 because these are 4 of the common programming language. And what we'll be looking at is the Pascal programming language. Now, what is a programming language? Anybody know what's a programming language?
Sir, a programming language.
Go ahead.
It's a form of a form of writing where you'd use code to give specific instructions to perform an action, to give the program an action, something to do.
All right. Or we can
The code
say,
that you use.
mhm.
Or words.
All right, good, very good. So let me check my internet. Give me a second. Let me turn off my internet and put it back on. Yeah, can you guys hear me again?
Yes, sir.
All right, thank you. I'm not sure what's going on with my internet today. Um, Let me run a speed test to see what's going on. Interesting. All right. Okay, it's going up slowly. All right. Could be when route to any problem. Either way. So, what is a programming language? A programming language is simply a method of creating a program. So, we have our goal is to create a program, and there are different methods of creating that program. And those methods are the various programming languages. Each language is going to be a bit different from the other, just like how we have languages that we speak and we write: English, French, Portuguese, Spanish, that you guys are also learning. Similarly, the program has different languages it can be written in. Just like how you can write an essay in English or Spanish or French and so on, you can write that program or create that program in a particular language of your choice. That's simple. So, whatever language you choose would depend on various things, various needs, because it's not necessarily one is better than the other, but in some cases, some are more useful in certain scenarios. It's like each have their own individual purpose, use for. Like for instance, Pascal. The Pascal language is not one that you're going to use to create large software. Like for instance, Microsoft Office, creating Word. You're not going to use Pascal to create that. You're going to use a more advanced programming language, such as C, or we have another one called C++ or C sharp, either one. Those more advanced programming languages you're going to use for those higher end software. But Pascal has its uses, even though it's not going to be used for those higher end software. It has its uses because it's a learning programming language. It's a programming language that you can use to teach because it's simple. It has simple concepts that can help you to learn the general idea as to how a programming language is structured. So it's like how when you're studying a language, whether it's English, French, Spanish, and so on, you start off with simple sentences. Similarly, Pascal has simple sentences that you can write and be able to do something. But as you advance, you start to creating essays, compositions, reports, things that require more information, more structure, more detail. So similarly, you have programming languages that are used for these higher cases. And for you guys, you need to not remember all of them, but just remember the most popular ones. So examples of programming languages. Do, 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 do. Wow. Yeah. So these are some examples of the most common ones. I'm pretty sure some of you have heard of Python. We also have Java. We have JavaScript, PHP, Ruby, SQL, Perl, C++, Assembler, C, HTML5, Lisp, COBOL, Objective-C, Swift, Scala, Fortran, Rust, Pascal, C Sharp. I'm just going to point out the popular ones. Python, Java, JavaScript, PHP, SQL, C++, C, um, COBOL, Fortran, Pascal, CSS, C Sharp. Those are some of the most popular ones. So, like I said, you don't need to memorize all of them, but you still need to know them. Like, what are examples of programming languages? Because in the exam, they could ask you questions like, which of the following is not a programming language? But notice they have HTML5 here as an example of a programming language. But I don't know if it's because HTML5 is a more advanced HTML. But please note that, as we would have learned last week, is HTML a programming language?
No, sir.
No, it is not. So it is what we call a markup language. That's what we would have learned when we were starting a web page design. So we're going to remember that basic concept for our exam. So once again, implementation phase, the first step, we take the algorithm, like for instance, this algorithm here, and we convert it into a programming language. And that is why also, why we gotta be so specific, why we gotta be so precise, why we gotta be so logical when we're creating this algorithm. Because it can be used for any programming language. You should be able to take this algorithm and convert it into C Sharp, convert it into C++, convert it into COBOL, Fortran, PHP, anyone. You should be able to convert it into. Why? Because it's simple. So that could be another one. Simple. It's straightforward. It's logical. It's precise. It's direct, telling you exactly what to do. So there's nothing vague about it. You're not questioning yourself. So it's easy to translate. Now, the second step for the implementation phase is to execute that program. What does execute that program mean?
Sir, to run it,
What?
to let show the results of the instructions.
Very good. To run the program. That's simple. Execute simply means to run the program, to see if the program is working, basically. And after the program is running, we see it is working fine, we carry out step number 3, maintain that program. What would you say is, how would we maintain a program?
By fixing bugs,
Good.
errors, possible errors in the code.
Fixing bugs. What else?
Updating it.
Very good. Updating. What else?
Sir, I don't know if you want to count securing the code as one.
Mm, all right. So security. What else? And we could add features. So those are some of the methods we can maintain the program. Because updating and adding features could be two different things. Updating could refer to as the system gets bugs, you send it an update, things like that. As you change operating system, you send it an update to let it run smoothly in that new operating system. But adding features is going to be like doing new things. So those are the 3 steps of the implementation phase. You take your algorithm that you would have created and tested in your algorithm phase, and then you convert it into a programming language. Then you run that program that you would have created, and then you maintain that program. So, are we clear on the two phases to solve a problem, algorithm phase and implementation phase? Are we clear on that?
Yes, sir.
The rest of you
Yes, sir.
clear? All right. Um, all right, let's continue. We are going to look at defining the problem. So remember defining the problem. That was step one here. So it's like a further breakdown of this step one, this problem definition. What else we can do? So let's look at that in a more detailed manner. So when you first analyze a problem, you should specify your objectives. What do you want to achieve by solving this problem? That is what the program is meant to do. The following four steps are used to organize and summarize a program's objectives. So, do you guys remember in Tort Farm we looked at a cycle called IPOS? Anybody remember it?
Yes, sir.
Yeah. What does it stand for?
Input, processing, output, storage.
Very good. And I think you guys had to review that when you would have entered EDPM, Fort Farm, and things like that. So, this cycle here, we would have learned is that it's a guide that the computer follows. Not really a guide, it's how the computer works. So it tells us as humans how a computer functions, basically. So a computer always starts off with that input stage. You put in data, then you process that data, you output the results of that data, and then we use storage to either temporarily or permanently store the data. So, for our program, we can describe basically those four steps because that's how the program has to work out. So, the program has to follow those four steps. So, we're not starting with step one, input. We're actually starting with our output. And the reason why we're starting with our output is so that we want to think about first what we want to achieve. So basically, knowing what is your objectives. So, or basically, you want to know what is the results. So, you not that you want to know, but you should know that this is what you want from the program. Like for instance, you want from the program that it tells you what's the weather every morning at 9 a.m. or 8 a.m. That's what you want from the program. So your output is that you want the program or the computer to tell you what is the weather at 8 a.m. every morning. That's the purpose of the program. So by knowing your result or knowing what you want from the program, you can be able to answer the other questions, input and processing and so on, by knowing your results. So that's why we can start off with specify the output. So by specifying the output, what kind of output are you expecting from this program? Will this output be numbers? Will it be text? Will it be numbers and text? Or even a graphic? So what do you want the output to be? Is this output in readable form? Like, are you going to see it on the screen? Is it going to be printed out? Or is it for input to another program? Are you going to send it to another computer? Are you going to send it to another device for that device to use it? Will it be displayed on a monitor as soft copy? Will it be printed? Or will it be stored in a file? So by knowing what is the result, by getting an idea of your objective, what you want out of the program, you can be able to answer the other questions, which are, what is your input now? Specify your input. So if you know what the output is, you can specify what values are needed for the input. So if you know you want the output to be the temperature or the weather for the morning, then you know as input, you have to put in weather data, how the clouds are moving, humidity, precipitation, all those fancy stuff, sunlight, and all those things, wind speed. You got to put in all those data. You would note that to get that output, you got to put in these particular inputs. Or simply, if you want the output, if you want your output as the output as addition of numbers, to make it simple, you want your output to be the addition of numbers. That's your output there. Then you should know that your input is going to be numbers. That's simple. You know that your output is going to be the addition or the results. You can say results of addition of numbers. We know that's our output, the result of addition of numbers. Then we should know that our input is going to be numbers. That's simple. So data. Now, how are you going to get this data into the program? So data can be captured by an input device such as a keyboard. You can transfer from a secondary storage device, or you could use a voice recognition system. Speak into the system, tell it what's the information, tell it what's the data. How are you going to get this data into the system now? That's your input question. Then the third aspect of the cycle, the processing part. How are you going to convert this input? How are you going to manipulate this input? How are you going to calculate this input to get your output? So what processing should be done on the input to get that necessary output now? How are you going to get your result from that input? For example, what calculations are needed? Is the processing grouped as a batch or completed in real time as the data is captured? How are you going to process the data? Remember, in third form, we looked at types of processing. Types of processing.
Yes, sir.
We looked at batch processing, real-time processing. Um,
Job processing.
yeah, that's the batch processing, job processing.
Oh, flow. There's flow.
Mm, what are the others? Can't remember the others right now. But there's like about four of them. And so yeah, you got to figure out how you're going to process the data. And then the last step of the cycle and your question, how are you going to store that data? What do you need to store? So determine how the data or the information or results will be stored either temporarily or permanently. So how do you need to store? What data do you need to store? Because remember, if your output is going to be the results of the addition of numbers, you got to input numbers. Now the question is, how are you going to store those numbers? So that's where this last question comes into play. How are you going to store those numbers so that you can process those numbers, basically? How are you going to store those numbers temporarily and then permanently store the results? So that is the summary of defining the problem. We have to answer those four questions. And that's basically like describing the solution. You can say you're describing what output you want, a particular output. What do you need to put in, your input, to get that output? How are you going to convert that input to output, which is your processing? And then what data do you need to store for that program, that algorithm? Any question on these 4 steps here? Are we clear on the 4 steps?
Yes, sir.
All right. All right, we are going to pause here for today. Next week, we are going to start with IPO charts. That's the next step for developing an algorithm, creating an IPO chart. So, what did we learn today? Remember, our overall goal is to create a software. That's our main goal, to create a software, to create a program. And what a program simply does, it instructs hardware, it tells hardware what to do. Now, how do we create a program? Well, first, we need to define the problem. That's our first step. Get a clear understanding about the problem. So that's the first step in the algorithm phase. Then we need to propose some solutions, evaluate it, look at the pros and cons, select the most reasonable one, and then create an algorithm. What is an algorithm? It is a sequence of precise instructions that is going to lead to a solution. It tells us exactly what to do. And then, when you're finished designing that algorithm, you must test it. What do we test it with? A trace table. We're going to look at that in detail later on. Then we looked at the implementation phase, where we convert our algorithm into a program. We must run that program to see if it's working. We maintain our program by fixing bugs, running updates, security patches, and adding features. And then finally, we just looked at a further breakdown of defining the problem. We simply answer the steps of the IPOS cycle. What do we need to input? What do we need to process? What do we need to output? And what do we need to store for that program? All right, any questions before we close? Any questions, comments, suggestions, clarifications, specifications? All right, no questions. I hope you guys are clear in everything. Remember, please ensure you are so that you can be ready for your exam. All right, if no questions, that is the end of today's class. Enjoy the rest of your day. Please remember to bring your SBA next week.
Yes, sir.